for Postcards from Buster is provided by the Arthur Vining Davis Foundations, dedicated to strengthening America's future through education. And by the Gill Foundation and the Annenberg Foundation. Funding is also provided by the following. This program was also made possible by contributions to your PBS station from viewers like you. Thank you.
Support comes from WMHT members and by Woodland Hill Montessori School, celebrating 40 years of inspiring joyful scholars ages 3 to 14. You can visit our primary, elementary, and middle school programs on our 11-acre wooded campus, 518-283-5400.
Oh, use your imagination. Use your imagination. PBS Kids and you.
Congratulations to WMHT's Student of the Month, Craig Gardner, a senior at Guilderland High. A congenital heart defect may have kept Craig off the playing field, but it couldn't keep him from playing an integral part in the sports program at school. As the hardworking manager of both the varsity football and basketball teams, Craig has won the respect of players, coaches, and classmates. WMHT is proud to name Craig Gardner Student of the Month.
You're watching PBS Kids.
This program is a presentation of the New York Network, a service of the State University of New York, and is produced in collaboration with the Teacher Resource and Computer Training Centers of New York State. Regents Review Live is sponsored by the New York Lottery and its Leaders of Tomorrow scholarship program. Additional support is provided by Waite & Associates, the assistance of the New York State Archives, Higher Education Services Corporation, the public television stations, and the Cable Telecommunications Association of New York State is greatly appreciated.
Hi, and congratulations for making the extra effort to improve your test-taking skills. I'm Bob McLaughlin, the director of the New York Lottery, a proud sponsor of Regents Review Live in conjunction with the State University of New York. The Lottery has a rich history of supporting important education programs like Regents Review Live, which has helped millions of high school students just like you prepare for the Regents exams. Consider this. Since 1967, the Lottery has contributed more than $31 billion in aid to education to support primary and secondary education statewide, with more than $2.3 billion of that total coming last year alone. Our success comes from being prepared and making the extra effort just like you are today. With that in mind, let's start today's session. And remember, you can call in at any time to ask a question. Just use the number at the bottom of the screen.
Hi there, and welcome to Regents Review Live, the television test prep program that brings 10 review sessions into your living room. Before we get to today's program, a few pointers for test day.
Pay attention, Carl.
First, you will need an ID to get into the exam. That's right. Second, all of those wonderful electronic devices that we all love to carry around will be located at the door, so it's best if you leave them at home. And finally, any attempt on your part to help one of your friends during the test will get you automatically booted from the exam. Not good. All right, everyone, hold on to your pencils, pens, and calculators as we rotate our Regents Wonder Wheel and initiate today's program. Good luck.
Welcome to Regents Review Live Math B. I'm Jenny Lever, a math teacher at Margaretville Central School, and your host for this afternoon. For the next 1.5 hours, I'd like to take your questions from previous Math B exams and give you detailed answers on how to solve those. And before we do that, I would like to point you down to the bottom of your television screen where you can reach me at that toll-free number, 1-877-264-9567. You can also visit our website at regentsreviewlive.net for better resources and more resources. And if for some reason I don't get to your question today, please feel free to email me at rrlive@yahoo.com, put Math B in your subject area, and I'll get to your question as quickly as I can. Before I take your questions, I'd like to go through the test format, what you should bring, and some test-taking tips. Your Math B exam is on Thursday, June 14th. It's an afternoon exam, so please check with your school district as to the exact starting time. You need to bring 2 pens, and they can either be blue or black, 2 pencils, a ruler, a compass, and a graphing calculator. And if you don't have a graphing calculator, your school will provide one for you. You have 3 hours to complete the test, and you must remain in the testing room until 2 p.m. Now the test has 34 questions, and you have to answer all 34 questions. There are 4 parts. Part 1 consists of 20 questions, multiple choice, 2 points each. Part 2 consists of 6 open-ended response questions at 2 points each. Part 3 consists of 6 open response questions at 4 points each. And Part 4 will give you 2 questions, and they're both worth 6 points each. Now, a formula sheet will be in your test packet, so when you get your test, you want to rip off your formula sheet and use that whenever possible during the exam. And to start with our test taking tips, I can't stress enough the fact that you need to read a minimum of 3 times. You want to read the question through to make sure you understand it. Then you want to go back and read the question to make sure you're definite what you're looking for. Answer your question, and then go back and read again to make certain that your question makes sense. So please read. Test tip 2, draw a diagram. Pictures are worth 1,000 words. They help you organize your data, they help you represent your information, and hopefully they will help you if you struggle along the way. Tip number 3, don't use a graphing calculator that you are not familiar with. You have to use a calculator that you've been using on a regular basis, otherwise your calculations could be wrong. Tip 4, if you get stuck, move on. Don't linger on that problem. Work some other problems that you know. You can come back to that problem, and hopefully something will click and you'll remember how to solve it. Test taking tip 5, you've worked hard. You're prepared. We're helping you today. Be confident in your math. You can do it. Tip 6, if you know your answer's wrong, you can't find your mistake, start fresh. A lot of times, if you keep working the same way, you're going to be stuck again. Put that paper off to the side, use a piece of scrap paper, and start all over. Tip 7, does your answer make sense? Remember, that goes back to the reading. Read, answer your question, and go back and make sure that your answer makes sense for the problem at hand. And tip 8, you have to show all your work. In order for us to give you credit, you need to show all your work in a nice, orderly fashion and make sure it's legible. And then go through the test. You don't have to do it in any certain order. Do the questions that you have the most confidence in, that you know, and do those first. So if after viewing this show you have any questions, again, please email me at rrlive@yahoo.com. Put Math B in your subject area, and I'll get back to you as soon as I can. Now, let's start reviewing. You're going to need a glass of water, your calculator, your phone, so you can call in the number at 1-877-264-9567, and let's get to work. I'm going to begin with a question from the January 07 Regents exam, and I'll do it over here on our Elmo. And this is question number 33, and it's a rational expression. And it says, perform the indicated operations and simplify completely. So for this problem, this involves factoring. And there are 3 steps of factoring. And you always want to go through the steps of factoring in the order that they are given to you. The first one is the greatest common factor. The second one is the difference between 2 perfect squares. And then the third one is to break down your trinomial. So if I look at this first fraction, I go through my steps of factoring, and I don't have a GCF. But this is the difference between 2 perfect squares. So I'm going to factor that using 2 sets of parentheses. One sign is positive, one sign is negative. My factors of x squared are x and x. Those go in the first positions. And my factors of 9 are 3 and 3, because 9 is a perfect square. Looking at the denominator of that fraction, I have a GCF. I have a greatest common factor of x. We're going to factor out the x. X squared divided by x is x, minus 5x divided by x is 5. And now our first fraction is factored. If I look at the second fraction in our problem, again I have a GCF, and I see that the GCF is x. We're going to factor out x. That's going to leave us with 5 minus x. And remember, when you factor, you want to check to make sure you are correct by multiplying back through. X times 5 is 5x, and x times negative x is negative x squared. In our denominator, this is a trinomial, and we're going to factor our trinomial by breaking it down into 2 sets of parentheses. My last sign is a negative, and my middle term is a negative, so I know that my signs in my factors are going to be opposites. Factors of x squared are x and x, and I need a factor of negative 12 that gives us a negative 1 when we combine. That's going to give us be negative 4, positive 3, and again, I would check your factoring to make sure that when you FOIL x plus 3 times x minus 4, you do get x squared minus x minus 12. We now have division, and I like to factor, and then I'll multiply by the reciprocal in a moment. This is not factorable, so I leave it as x minus 4. And my trinomial, I can factor into x minus 4 and x minus 4. And again, I would multiply that out to make sure that you are correct. Division always changes to multiplication. We're going to multiply by this reciprocal. So I'm going to rewrite all my other work. Sometimes my students tell me, but Mrs. Lever, this is so much writing. The more precise you are and the more neat you are, generally the more accurate your work, and without skipping a step, you'll be successful. Now we've reached the division. We're going to change that to multiplication. We're going to multiply by the reciprocal. X minus 4s all over x minus 4. Now at this point in time, this is a rational expression. We need to simplify by reducing. Remember, we reduce numerators with denominators, and it can be any numerator in any of the 3 fractions and any denominator in the 3 fractions. So I take a look, and I see an x plus 3 in the numerator and an x plus 3 in the denominator, and I know that x plus 3 divided by x plus 3 is 1. I keep looking, and I see an x minus 4 in the numerator, another x minus 4 in the denominator. X minus 4 divided by x minus 4 is 1. And then we have an x minus 4 divided by x minus 4. That's a 1. Here's an x divided by x. That's a 1. And now I look here, and I have in the denominator an x minus 5, and in the numerator a 5 minus x. They appear to be the same, but they are not. The 5 in the numerator is positive, and the denominator is negative. The x in the numerator is negative, the x in the denominator is positive. Because the signs are opposites, I can reduce those, leaving a negative 1, and I tend to put my negative 1 in my numerator. You can put in the denominator or the numerator, your choice. So if the signs are opposite, you can reduce those, leaving a negative 1. So then I look at my rational expression. The only thing left in my numerator is x minus 3 times the negative 1. There's nothing left in my denominator. That's just 1. I'm going to simplify this by negative 1 times x minus 3. I can write 2 ways. Negative x minus 3, or I can distribute that negative sign in to give us negative x plus 3. And there's your simplified rational expression. Okay, what I'd like to do now is I'd like to go to January 2007, and I'd like to do question number 27 for you. Remember, you want to call in with your questions because this is your review time. Please call me at 1-877-264-9567. And the next question I have for you, you'll need your calculator for this, is to find to the nearest degree all values of theta in the interval from theta between and including 0 and 180 degrees that satisfy the equation 8 cosine squared theta minus 2 cosine theta minus 1 equals 0. Well, the first thing you want to point out is it says in italics, nearest degree. Pay close attention to that. Chances are that this is not going to be a nice degree and you're going to have to do some rounding. Also, pay attention to your interval. You're only using quadrants 1 and 2, and that will be important. Here's our problem right here. It is a quadratic equation because we have the squared term. We set that equal to 0. We're all set. And now what we have to do is we have to factor this. Now, generally, if it says nearest degree, it's not going to be factorable. So what I'm going to do is I'm going to use the quadratic formula. You can do the quadratic formula, you can factor. So I'll start with the quadratic formula. Cosine theta equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Off to the side, I tend to write what our values for a, b, and c are. A comes from the number in front of our quadratic term, so our a is 8. B comes from the coefficient of the linear term, which is negative 2, and c is our constant, negative 1. So I'm going to continue here, and we're going to substitute in, and don't skip any steps in your substituting. That's where errors occur. Write everything down. Hopefully you can earn some points. And remember, a is 8. So we're continuing. This is cosine theta. Negative 2 is a positive 2. Plus or minus. Negative 2 squared, 4. Negative 4 times 8, negative 32. Negative 32 times negative 1, positive 32. All over 8 times 2 is 16. We're going to combine what's underneath our square root, giving us 2 plus or minus the square root of 36. Now here's a tip. 36 is a perfect square, which means that I could have solved this problem by factoring. Quadratic formula always works. It's your choice what you'd like to use. So we're going to continue. Cosine theta equals 2 plus or minus the square root of 36 is 6. All over 16. And we have two sets of answers. We have cosine theta equals 2 plus 6 over 16, and we have cosine theta equals 2 minus 6 over 16. We're going to combine. 6 plus 2 is 8. 8 over 16 reduces to 1/2. We're going to work the other side as well. 2 minus 6, negative 4 over 16. Theta is negative 1/4. Now we're not done. Remember, the question asks us to round to the nearest degree. We have two scenarios that we have to work, and we're going to work our left side first. Now, from last year's show, one of the callers told me this little saying, all students talk constantly. I also used to teach my kids all students take calculus, but I liked all students talk constantly. And this tells us where cosine is positive. Cosine is positive in quadrants 1. All trig functions are positive in 1. And C stands for cosine positive in quadrant 4. So what we're going to do is I'm going to put my calculator right here. And I'm going to zoom in for you so you can see this. And we have a question that says we need to find what value of cosine gives us 1/2. So we're going to use our calculator and we're going to push the button second cosine of 0.5 or 1/2 equals, and that gives us our degree. Our degree is 60. So I'll go back to the work, and I know that one value of theta is 60 degrees. That takes care of quadrant 1. We still need to take care of quadrant 4. And to get to quadrant 4, we use 60 as our reference angle. We're going to subtract our reference angle from 360 degrees. 360 degrees minus 60 gives us 300. And then we can check ourselves on our calculator. I'm going to check to make sure that, in fact, the cosine of 60 degrees is half, true, and the cosine of 300 degrees is half, true. So I know that that side of my problem is correct. But I'm not done. Don't forget, I have another other side of my problem to do. This time, cosine is negative. That tells us, the negative, that we're working with quadrants 2 and quadrants 3. So I'm just going to write down quadrants 2, quadrants 3, to remind me that the first value I get will be my reference angle. Remember, the negative tells us the quadrants to use. I'm now going to ignore the negative sign. I'm going to come to my calculator, and now what I need to do is I need to find the cosine value of what degree gives us a quarter. And it's second cosine, 0.25. Now you can see that's 75.5. It asks for the nearest degree, so on my calculator I press second angle, and I want degrees, minutes, second, which is choice 4. 75 degrees, 31 minutes, and that's what I write down. 75 degrees, 31 minutes. Now, to the nearest degree, 30 degrees and above, 30, 40, 50, moves your 75 degrees up 1 degree, so 76 degrees is going to be my reference angle. Notice 76 degrees is in quadrant 1. Our answers have to be in 2 and 3, so 76 just is my reference angle. Now again, I set up my quadrants, and I have to use 76. Quadrant 2, I'm going to take 180 degrees, subtract 76, takes me backwards to 104 degrees. That's going to be one value for theta. To get to quadrant 3, I'm going to take 180 and add 76 degrees. That's going to give me 256 degrees. Now I have totally finished my problem. I have two answers of 60 degrees and 300 degrees, and two other answers of 104 degrees and 256 degrees. And then just go back. Remember what I said about read the question, read the question, read the question? Go back and read this question. We only need the values that fall in the first and second quadrant between 0 and 180. So that means our ultimate final answer would be 60 degrees and 104 degrees, because those fall in quadrants 1 and quadrants 2. Super. On our line is Courtney from Rochester. Hi, Courtney. How are you?
Good, how are you?
I'm excellent. Thank you. What can I do to help you today?
I had a question on the August 2005 exam.
Okay, let me just turn to that. And what part?
Part 2,
Super. And which number is it?
number 21.
21. I'm going to do this one over here on the smart board. And this question asks you to evaluate. Now, Courtney, my students always laugh at my summation symbol, so please don't laugh today.
Okay.
N, the sum of the values from n runs from 1 to 5 using the formula n squared plus n. So there's our question. We have to evaluate it, so we must get an answer. Now, Courtney, what all this says is use your values from 1, plug it into your formula here. So I'm going to start right here, 1 squared plus 1, and all I'm going to do is plug it in. The sigma symbol in math means to add, so I'm going to add. Now instead of using 1, I'm going to use my next number, 2, and I'm going to plug it into my formula. So that's 2 squared plus 2. Again, I'm adding. And Courtney, what I have to do is I have to work my way all the way up until I substitute 5 in. So the next one's going to be 3 squared plus 3. And then we're going to add 4 squared plus 4. And then we'll add 5 squared plus 5. So that's all that the problem means. And now all we have to do is evaluate. And again, don't skip any steps.
Okay.
1 squared is 1. 1 plus 1 gives us 2. 2 squared is 4. 4 plus 2 is 6. 3 squared is 9. 9 plus 3 is 12. 4 squared is 16. 16 plus 4 is 20. Oh, lovely. Let me fix that. And then 5 squared is 25 plus 5, 30. And then, Courtney, all we're going to do is add them up. 30 plus 20 is 50, plus 12 is 62, 68, 70. Should be your answer.
Thank you.
Thank you for calling in.
Okay, bye.
Have a good day and good luck on the test. Super. Giovanna, welcome. Giovanna's from Lancaster. How can I help you today?
I had a question on the January 2005 exam.
Okay, let me turn to that. And what part is that?
Part 4.
Part 4. Ooh, one of those lovely 6-point questions. Okay, which problem?
Number 34.
34. How's the weather in Lancaster today?
It's nice out.
Very nice today. Oh, nice problem, Giovanna. This is a problem that, I don't know about you, Giovanna, but I am not an artist.
Yeah.
I don't claim to be one, so this is a very good problem to challenge us on. A sign 46 feet high is placed on top of an office building. Remember from my test-taking tips, you want to draw pictures. Now, don't laugh at my pictures because I'm not the artist, but there's our 46-foot sign on top of a building. And I'll move that up and out so you can see that. Now, from a point on the sidewalk level with the base of the building, the angle of elevation to the top of the sign, so I'm going to use my ruler to draw this in. And if you notice, Giovanni, what I'm doing is making myself a right triangle. I'm going to put my little right triangle mark right there. Okay, let me come out. The angle of elevation to the top of the sign is 40 degrees. So this whole angle right here is 40 degrees. And then the angle of elevation to the bottom of the sign is 32 degrees. Now, this is the tricky part. This is the 32-degree angle there, and the big angle is 40 degrees. That makes this little angle of this triangle 8 degrees. So you want to substitute that in, and that's been a trick area in the past. So your job is to sketch a diagram, which we just did, to represent the building, the sign, the two angles, and find the height of the building to the nearest foot. So I'm going to let the building represent X. Off to the side, up above here, I'm just going to let X equal the height of the building. And I see that I have two triangles here. So probably what we're going to have to do is use either the law of sines or the law of cosines or both to figure out the height of this building. And before we can figure out this height, chances are we're going to have to use this triangle. I'll label it A, B, C. And what we're going to do is we're going to find length BC, and then that will help us find, and I'll label this point D, BD, the height of our building in the problem. So I'm going to let BC equal Y. And then I think what we can do is we can use, we've got a 46-foot high, so this right here is 46. That's opposite this angle. And then we don't have any other height. So I guess what we're going to do is pull this triangle out for you so you can see it. 46 and 8 and Y. Okay. And then what we're going to do is we're going to use our formulas. And I'm missing something here in the reading. So let me go back. A sign 46 feet high is placed on top of an office building from a point on the sidewalk level with the base of the building, the angle elevation to the top of the sign, and the law, okay, got the angle. So let's find this angle right here, because so we've got 90 degrees, we've got 40 degrees. 90 plus 40 is 130, and then 130 subtracted from 180, because this is a big triangle, is 50 degrees. That's what I was missing right there. So this angle's 50 and this height's 46. That's going to mess us up. Okay, so we're going to use law of cosines. We've got an angle, a side, no, we're going to do sines. So we're going to do 46 over the sine of 8 degrees, which you can see right here. Here's the side 46, here's 8 degrees. This angle is 50, so we're going to do y over the sine of 50 degrees. So Giovanna, we're going to set up that ratio, that proportion, and we're going to solve that. I tend to tell my students, don't find the sines until you get to the end because the calculations are larger. So we're going to cross multiply. Y times sine 8 is y times sine of 8 degrees. Then we're going to cross multiply over here and do 46 sine 50 degrees. And we're looking for y, so we're going to solve for y by dividing both sides by sine 8. Sine 8. And now at this point you're going to use your calculator. My calculator is not showing up great on the Elmo, so I'll just do that off to the side. And what you're going to do is you're going to multiply 46 times the sine of 50. Please make sure if you're doing this entirely on the calculator, you use your parentheses. Then you're going to divide by the sine of 8, and you're going to get the number 253.1957982. Now, Giovanna, I tend to tell my students to use all decimals and not to do any rounding until the very end, because that could affect the answer. So I'm going to use that to go to this triangle here, and then I'll just sketch that triangle so you can see that we're using the smaller triangle down below. This is DB. X is what I'm looking for, 90 degrees, 32, and then we just found that side. And you have two choices. You can use right triangle trig, opposite over hypotenuse, so you could do the sine of 32. Or you can go back and you can do your law of sines again by setting up x over the sine of 32 degrees equals our large 253 that we found, 253.1957982, divided by the sine of 90 degrees. So again, it's the opposite side over the sine of the angle, opposite side over the sine of the angle.